an addendum to the trig. I guess I'm labeling it as trig review 2. So if I have a right triangle, and this length is A, B, and C, and I have some angle here beta, some angle here alpha. We've already talked about the trig relationship here, but so we'll just put those down. Cosine of beta is A over C. The sine of beta is B over C. The tangent of beta is B over A. Or A over C is also the sine of alpha. That's equal to the cosine of alpha, and this would be the cotangent of alpha. Or we could just do tangent of alpha is A over B. So if I gave you a triangle here where I gave you the sides, let's make it a right triangle. So if this is 7 and 11, what are the angles and what is this right here? Well, first we can get the hypotenuse easily enough. It's a right triangle. Pythagorean theorem holds true. For those who want to do more work for themselves, use law of cosines, but Pythagorean theorem is fine. So if I label that as C, 7 squared plus 11 squared equals C squared. So this is equal to 170. And so C is equal to 13.0384. I'm not worrying about significant digits at the moment. And so on. So I know what the hypotenuse is. Now I need to find the angle, so I'm just going to label this as alpha and this one as beta. It's whatever letters you want to use, something that's not being used already. Don't use a capital C because it's hard to tell between capital and lowercase c's. So I'm going to use these relationships here. So I could do cosine of beta, and that's going to be 7 over 13.0384, yada, yada, yada. But recognize this has some rounding involved here. Now I could be slightly more precise and do 7 over square root of 170, but my calculator is still going to round off at some point. And so typically you want to do the sides that have less rounding involved. So I'm going to use the tangent of beta is equal to 11 over 7. But I'm trying to solve for beta, so I need to get this tangent out of here. Well, how do you get rid of tangent? By doing the arctangent. So I'm going to do the arctangent of both sides. So I'm going to do it to both sides. I'm good to go. The arctangent of the tangent, those cancel each other out, so I'm left with beta is equal to the arctangent of 11 over 7. And so beta is 57.53 degrees, rounding off. Alpha is the complement of it because I know that angles have to add up to 180 degrees in Euclidean geometry and for everything that you will be doing unless you start getting into curved space and time. And so alpha will be the complement of that. So that makes this 32.47 degrees. I could have also found alpha by doing, I know that alpha would be the, well, let's do it step by step. The tangent of alpha is 7 over 11, opposite over the adjacent. So alpha is the arctan, and I'm going to abbreviate just a little bit there. Writing out arctan, this is the way my calculator presents it, so I will do that often enough. So 0.7 arctan, and I get, 7/11ths. And I get 32.47 degrees. Hey, how about that? It's the same thing as down here. I do want to point out a notational bit here. When we're dealing with arctan, there's 3 ways of expressing it. So we'll just take that one right there. So alpha is the arctan, actually writing out arctan. You could write out arctangent, so I guess that would be another way, is 7 divided by 11. Or as my calculator will do, and sometimes I'll do to abbreviate it just so I write less, arctangent. Or as most of your calculators will have, unfortunately, the inverse button there, so 7/11. It is indeed an inverse trig function. I'm really not a fan of this notation, even though I understand what students are doing, and so I accept it. But the problem is that, so if I have tangent of alpha squared, that is generally written as tan squared alpha. It's understood I'm squaring tangent of alpha. If I have tan alpha cubed, written as tan cubed alpha. And it's understood that this means I'm taking the tangent of alpha and cubing it. But if I want 1 over the tangent of alpha, using exponential notation, that is tangent of alpha to the -1. But it's not written as tan -1 alpha. These are not the same. Because the notation that is being used here is that this is the inverse trig function, and so this would be equal to the cotangent of alpha. This is equal to the arctangent of alpha. And so this is why I'm not a fan of this notation, is the fact that it suddenly breaks the pattern of how these things are expressed. And, you know, it could just be a me thing, but there it is. I hope there's no video of me actually writing the inverse trig function that way.